You're in for it on the first row there. It's audience participation stuff. I'm kidding. I'll get to that. So, well, it's 3:30, so I'll get started. So, Dad and Principal Product Managers, in fact, 2 titles. It's not 1 title. So, Dad is my home job, and Product Managers at Red Hat. Thanks for all coming on a Thursday. You should get a door prize for showing up for a late Thursday session. So, congratulations for being here. So to explain the title here, let me flip into 2 important people in the story here. You're probably familiar with Sage Weil, who he's 38 years old. He's the creator of WebRing, co-founder of DreamHost, created Ceph, founder and CTO of Inktank, PhD from UC Santa Cruz, and he can successfully install Ceph. And on the right is my daughter, Olivia Applewhite. She's 10 years old. She's a 4th grade student at Easley Elementary. She's my daughter, and she can install Ceph too. So I'm going to show you that. So, yeah. So how about girls in tech? That's a start, right? So this is the user acceptance testing, picture here. So this is her getting started on a Ceph installation. She decided to name her cluster Squidward, after I explained to her, what a cephalopod was and what it was all about. So these are the steps, some of the steps that happen when you install a Ceph cluster. You can't actually see the full history there, but it took about, I'll get into the results in just a second here, but that'll give you an idea of what it's like to install Ceph. For those of you, how many of you have installed Ceph sort of the manual way? Do you think your 10-year-old daughter could do it? If you had a 10-year-old daughter, could they do it? Okay. I was guessing the answer for Ceph 1.3 was probably no. So this is a change. So the results. So it took. I gave her about 1 to 2 minutes of instruction how to install Ceph. I told her some choices. You're going to have to make sure you select 3 mons. She's like, "What's a mon? Don't worry about that. You need 3 of them, and you're going to need 3 OSDs in this environment." And it took her, 1 or 2 minutes to click through the naming the cluster and deciding, just sort of taking the defaults. She didn't change the networking or anything. And it took about 15 minutes to install a small 6-node cluster. The legal guys asked me to verify and state that we can indeed install Ceph in less than an hour, and we can. So it's small. This is a small cluster, but I mean, honestly, how much storage does a 10-year-old girl need? Especially, Ceph cluster. So here's the agenda today. To get a little bit more serious, I'll do sort of a little bit of the business value of Red Hat Storage Console 2, talk about the architecture a bit so you kind of understand the pieces of it, and then I'll go through the remaining items here. I actually have a demo. I'll show you the same screen that my daughter, the screens that she went through to do an installation. So the first thing is what I've already covered, that you can obviously install Ceph in much less time than it previously took to do that. That was one of our key use cases, something that we wanted to really nail, and I think the team has done that. By the way, our dev lead, Nishant, is over there sitting. So the business value of that is that it reduces your schedule risk. If you don't know how long it's going to take to do something, there's risk around it, as many of you know and been in operations. The other benefit is that it ensures best practices, so it's going to prevent problems down the road. We put a lot of effort into making sure that all the configuration settings and tweaks and everything that make Ceph operate well are put into that. So that's a primary value of it. The other thing is that you can provision Ceph. You can provision usable RAID-offs or RBD storage in seconds. It's a similar kind of wizard. You click through, you can provision the storage, and then see later how that shows up in your storage pools. So that gives you increased efficiency of operations. It just simply takes less time to do common operations. And then on the monitoring side of things, it gives you, I'll show you, in the videos, you'll see the dashboard and a way to manage the health and the performance of the system. You can see the capacity utilization over time and sort of gain intelligence about what's going on. So some of our customers tell us, we have a really large Ceph cluster, but we don't really know what's going on in it. So the storage console is really going to make a big dent in that, I think, and hope to give people a better idea of. The other thing is it'll give them, projections of when do they need to add nodes if they're running out of space in their, their pools. They need to add OSDs or additional nodes, so they'll get that kind of, projection from it. And on the other side is the alerting. If something's going wrong that needs the attention of an administrator, it'll give you that. It has a framework for doing alerting. It also has thresholds that can be triggered. If you've been in other sessions, you might have heard Sage mention that a full OSD can actually stop operations to the cluster. So that's a serious event. So it's something that we put thresholds in place. So you get alerts about it. You're not going to be exposed to not knowing, that you're at risk for that kind of thing. And that enables you to meet your service level objectives. So moving on to a little bit of the sort of the architecture of the current storage console. So on the top right, you'll see users come in and they interact with the Katoon web UI. So that's a component within the framework that is based on pattern-fly, displays to the end user the information that it gets from the underlying components. And it's purposely separated off from the sort of the business logic aspect of it. And then it interacts with the SkyRing service that has deployment through Ansible, which I'll talk about a little bit, the management code, and the monitor, and the DB. And then the SkyRing interacts with the SkyRing Common for the eventing and the tasks and some of the time series information that goes into Graphite. And then over on the other side, the BigFin Ceph provider interacts down with Ceph itself. So the bottom three nodes that you see are Ceph. I only put one mon here. Normally you'd have at least three, just to sort of illustrate the architecture. So the BigFin provider talks to Calamari API and the Ceph nodes, and then also interacts with the agents that are running on all the OSDs, the Skynet nodes. So that'll give you an idea of how things are architected. This is just a visual of the storage console to get an idea of what pattern-fly looks like. You've probably seen, if you've been through some of the booths, you've probably seen similar interfaces. It's a very common sort of framework that Red Hat uses throughout many of its UIs. So you can see that it gives you, utilization, and I'll show you the video to give a little bit more moving bits there. So I'll dive into some of the features. So I mentioned, that it does install Ceph. We've kind of covered that. It does manage and monitor the health and the performance, the capacity. That's an important thing for a storage admin. Provision RADOS and RBD, block storage, alerting and operational issues. And you can do that either through an email. You can configure an email to your SMS gateway, get events on your phone, or you can also set up if you have monitoring systems and you'd like to query some of the APIs, probably at some point we'll have a good documentation. We don't have it yet. We're shooting for having some better documentation around the APIs, but they're RESTful APIs, so you can just call APIs to get information about events as they come in, and then those could bubble up through your own monitoring system, whatever you happen to use, so whether it's Nagios or some of the other things. There's also integration into enterprise authentication schemes like Active Directory and LDAP. If you want to do authentication through those systems, you can configure that, and the console will hand off the authentication part to those backend systems. And then there's also the cluster and per node usage information. It gives performance, I/O statistics kind of data as well. And then also talk about a little bit. There's really two modes for installation with Ceph 2.0. Ceph Deploy is it's still there, but really we're preferring Ansible. There's sort of a headless Ansible unattended mode if you want to do that. the storage console still leverages Ansible underneath the covers, so it's making calls and doing the installation of Ceph through Ceph Ansible. Another feature I haven't really talked about is the ability to import existing 2.0 clusters. So if you have an existing Ceph cluster, you want to upgrade from 1.3 to 2.0, you can then import that into the storage console using the import feature. It just requires that basically the salt minions are running on those nodes, and then they can be registered with the console through a couple of web endpoints that you hit to get a registration script. And then once you've done that, you can bring your cluster in. Also, ability to, as I mentioned, you can discover and add hosts. And so as you grow your cluster, over time, Ceph is never static. You're always needing to add storage, typically in modern environments. So it's quite easy to add hosts and add them to the pools. And I'll talk a bit about some of the stuff that we do around setting up your your pools for you and the crush rules in a little bit. Obviously, you can create a cluster, or you can also remove or manage that cluster if you decide you want to sort of cut it loose from the storage console. I talked about that already. You can also, with OSDs, you can also set the state on them. There's a video where you can see some options around the OSDs. You can also classify them by different thresholds, like which ones are nearing full, so you can graphically see, okay, these OSDs are getting above a certain percentage, and you could take action on those. You could reweight them or do some of the things that you typically do to kind of rebalance the cluster. Also ability for storage pools themselves to be created or resized, as you'd expect. And then I'll talk about storage profiles here in the next slide. There I've actually got a visual, but the idea here is that you can classify your disk. So if you have SSD disk or SAS or general purpose disk, SATA disk, you can classify those, and then actually the console will create a pool for you based on those classifications. So it's pretty useful. So basically, you can see in this example, it's kind of hard to see it, but this is a drop-down of the various disk types that the console detected, whether they're SAS or SSD or general. And so on the fly, it creates that pool, and it maps the pool to those underlying OSDs. So the advantage of that is that you kind of have a catalog of different types of storage hardware. So if you want to have particular workload that needs better performance, needs low latency, you can map that to a pool that's based on flash storage or an NVMe or, a variety of faster hardware. Or if you need, conversely, sort of an archival pool for SATA, you could do that as well. So as I think I mentioned also, you can provision volumes with the pool as part of a single operation if you want to, and I'll show you that in the next demo. The other thing is that you can create standard replicated or erasure-coded pools. So you're probably familiar with erasure coding. It's essentially, in a software-defined system, it's kind of like RAID, where you are mathematically computing parity and reducing the amount of space that that storage is going to take on the underlying pool. So the trade-off is sometimes it takes a little longer to recover from those. So, but there's good use cases for that. There's also a quota management feature on pools, so you can enforce quotas at the pool level. Ability to resize or delete RAID block devices. View them as well in a list view, and create and update local users or LDAP users, as I mentioned. And then there's an event engine as well. So that's one of sort of the core pieces that we had to develop early on with the console, was ability to sort of manage events and handle the severity of them, categorize them, so you can filter them or dismiss them if you need to. I've already seen this event, I've addressed it, dismiss the event, get rid of it, that kind of thing. And then you can list those in a list view. You get cluster-wide thresholds, as I mentioned, and cluster and mon-status. So this is obviously a very important thing with Ceph, to get sort of a Ceph -S or different various sort of cluster status state within the console itself. All right, and then also there's a logging framework. This is basically for the console itself. I'll talk about the roadmap in a little bit and a little bit more advanced things we want to do around logging, but we have basic, logging for the console. I mentioned email alerting. Okay. Capacity utilization. IOPS is an important thing to keep up at sort of at the cluster level. How many IOPS can you actually serve? So you get that information through the console. And now I'll go into a demo. This first one here is what you would have seen, what my daughter saw when she did the installation here. So first of all, you'll see in the top right, you can see nodes that have been discovered. So these nodes have been registered with the console, but you don't have to accept them up there. You can just go ahead and you can create cluster. You give it a name. You can set the journal size if you want to. Then you select the hosts, and here she would have had to set the mon status. This is where you classify disks. So you can see, in this case, we had general disks, so they all show up under that category. Had we had SAS or SSDs in this system, they would have automatically shown up classified. And you can drag them around if you want. If it's unknown to the system and you want to drag them into a different storage profile, you can do that. And at that point, once you selected the cluster networks and all that, you can go ahead and submit the job, and you're good to go. So, and that, as I mentioned, that took, it takes, you can see it takes a minute or two to get through, the information that's required to do the creation. This is also similarly really simple to create storage. You basically, you click Add Storage. You can select the type, whether it's RADOS or RVD. In this case, it's RADOS. You could either go erasure coded or not. There's a lot of intelligent stuff that the console's doing for you here and calculating placement groups and whatnot. So that's it. You submit the job. You'll get status eventually on the success or failure of your job. Yeah.
If I wanted to give it a custom crush map, not the one that it was suggesting based on all the hardware types going on, is there a way to do that?
Editing crush maps is not really in scope here, but we can create crush maps based on the hardware profiles pool. So there's some custom creation sort of at the outset, but not advanced editing down the road. That is on the roadmap, but yeah. Okay, so in the same way, we did the RADOS block device. And then here, this is the task management pane. So you can see you can get details on a task and see the tasks and the subtasks that are associated with it. Pretty straightforward. And this is kind of a mix of a variety of features here. I'm going to show you events. Also in the dashboard, I'll highlight. It shows you about the most used pools. You'll see information about CPU, IOPS. You can show all the. So I'll go ahead and run this here. So there you'll see an event popping up. This is a cluster health warning at the top. It's kind of hard to see, but it's basically a warning that Ceph went into a health warn status. Here you're seeing the dashboard. You'll see most used pools. If there was better data here, you would actually see the pool percentages and where you are, how much storage you have left. This is the cluster panes, so they'll just sort of walk you through the various panes here. You can see the host tab, the pools tab, the RADOS block devices, the OSDs, and the cluster configuration. Then this is the configuration pane for setting up your email alerts and also for your LDAP users. So I know this is kind of rolling by quick, but don't want to spend too much time on it. So, and then you might be wondering, well, this looks good. How do I get it? So the good news is, if you're a Ceph customer with Red Hat, you get this free of charge. It comes basically bundled with Ceph 2.0 when it comes out. We're going to release those in tandem. So it can be consumed either, as a sort of a layered install on RHEL 7.2 if you want to lay down with, your tools, your infrastructure, lay down your RHEL host according to your build and then install it. You can do that. Or you can get it as a pre-built QCal image if you want to just rather run it in a virtual infrastructure like Rev or OpenStack or something like that. So really two ways to run it. Yeah, you got a question?
How does it go to discover which servers?
Okay. Yeah, so basically, once let's say you got a RHEL server up, you got your console up, there's a couple of, you run a curl command and it pulls down a script. You can then look at the script, you run it, and then you run a second script that's also on that URL. And once you've done that, that'll register the node with the console. And Nishant, correct me if I'm wrong, but I think that's it, right? Yeah, that's basically it. The console itself is running. It's kind of a shell script, so it gives you the scripts that are needed to register with it. So you just hit port 8181 and / console or agent and pull down a script. You can look at it before you run it, or you can pop it into Bash if you're feeling really adventurous. So yeah.
Does this work on a community edition, or you solely?
Yeah. I'll talk about that in a bit. All this code is upstream in the SkyRings project. We're going to be maintaining that for the 2.0 release, and then we're going to be renaming it into the Tendril project. And I'll get to that in a bit, but yeah, it's upstream. Yep.
For the email alerts, can you set up for the hardware component as well, like a fan tail?
We don't really have integration for like the RHEL layer. That is something that's on my roadmap, and I'll talk about that in a minute. But yeah, we got basic alerting for events that happen within the nodes within the Ceph context. So let me switch to, so that's Red Hat Storage Console 2, and so we're trying to move basically towards more unified storage management as a strategy, and we'll be bringing in Gluster as a primary, as the next thing for that. So we truly will have a unified manager for that. So we'll be renaming the product to Unified Storage Manager, and it'll be 3, that version when it comes out. Some of the themes for the USM3, for short, are to enablement for Gluster 3.2. So there is an existing, some of you may be familiar with the existing console for Gluster. We'll be replacing that and updating it for Gluster 3.2. The Ceph UI that you've seen, it will be essentially unchanged in the next release with some, a few new features. The primary focus on the next release will be Gluster. We'll be doing, probably a couple of things for Ceph. And then we'll be doing some technical enhancements. We're kind of moving to a little bit more of a stateless model, so we can have 2 or more nodes in a sort of a high availability configuration, and they'll be containerized. And a little bit of refinement around the way we handle actions and events. Basically the goal is sort of pivoting to a stateless, highly available, service-oriented focus, so that we can integrate with other components. We don't want to be the only management tool. We're going to be integrating in with a lot of the other products within the Red Hat suite, OpenStack Director, the CloudForms management tool, and that CloudForms obviously gives you a lot of higher level visibility into virtual machines and being able to peer down through the virtual machines and seeing where their storage is, and so we'll be integrating into that as part of the strategy. And then Red Hat Insights, if you hadn't heard about it, it's essentially it gives you, at least for RHEL, the base RHEL, it gives you predictive notifications about things that might be a problem for you. For instance, you're running this version of RHEL, you need to tweak your network stack, otherwise you're going to have decreased performance, or there might be a availability alert or a security alert, or things like that, that Insights handles for you. And I'll get into a little bit more about that in a minute. As far as from the present Gluster console, the big change is that instead of sort of a task-oriented, a feature-oriented model, it'll be a little bit more of a workflow model to sort of get you from raw device to usable provision storage for the end application or the user in as a few steps as possible. Basically, be the strategy, kind of in time to value. As I mentioned, we're going to be integrating into the Red Hat portfolio. It's called Cloud Suite. There's a number of applications within that. So we want to be, have exposed northbound APIs to other applications that can make calls to the service and get things done with storage, so they don't have to handle all those low-level primitives. We'll kind of offload that and provide that service. Kind of a middleware strategy, I guess you'd say. And our focus will be on software-defined storage only. No real focus on enabling hardware directly, arrays or anything of that sort. Let's see. I mentioned, we'll be integrating with the portfolio. The other thing that's, this is more for probably programmers, but we're using the Swagger framework, which is a way to auto-generate API documentation and actually view APIs in an interface to efficiently be able to kind of browse the APIs and discover them and find out what you need to do to interact with the service. So it just increases the efficiency of trying to integrate with it for a developer. And on the Gluster side, as I mentioned, Gluster 3.2 is really one of the main targets for the next release. We'll have a single, unified manager then for Ceph and Gluster, which will be exciting. We'll do installation probably based on, some of this is still being scoped for the next release, but we're probably going to be using gdeploy for the installation at least. There's also discussions around Haketi for other operations. Some of you may have seen a session earlier on Aplo, which is a way to provision storage for OpenShift through Haketi. So it has a lot of intelligence that we have to bring in either directly or through a library or something like that. So, and the same strategy as you've seen with Ceph, it'll be provisioning, monitoring, alerting, graphical interface for Gluster as well. Same approach to reduce the cost, complexity, time to value. So just to give you an idea of what I'm talking about when I talk about workflow. So an example would be, the process of provisioning storage in Gluster would be, create your bricks from devices from your physical devices. You've got to, you probably have to format them with XFS. You can then create the distributed replicated volume. You got to start the volume. If you want NFS access instead of native cluster, you set that up, and then maybe provide in sort of an Amazon-like way, provide the mount string for the end user to actually complete the process, so they can get from beginning to end with very little trouble. So. On the Ceph side, Ceph in the time frame we'll be releasing Ceph 2.1 will be out, so we would obviously do some testing and make sure that Ceph 2.1 is fully compatible, and also probably add some enhancements around replication, like Redis block device replication for DR scenarios and things like that. And then on the OpenStack side of things, as I mentioned, we're going to have support for OSP because other services are going to be consuming the APIs of USM. There's not a ton of work for us to do around that. It's basically an integration effort with OSP. And then so initially you'll see that there's sort of day two management. OSP will do the installation, Ceph will be provided through that, and then we can import the Ceph cluster into the console and provide sort of day two management through the console there. And then the tightest integration will be really more in like the OSP 12 time frame. So. And on the technical side, sort of the technical debt side, as I mentioned, we're going to be going with more of a stateless model. We still have we're shifting our key value store to etcd that you might be familiar in the OpenShift world. And we'll also try to be a little bit better about out-of-band operations that happen outside of the console, knowing what's going on in user land, other people creating objects or deleting objects, things like that will be a theme around the USM 3 release. And then also a little bit of refinement around actions and events and the monitoring aspect, sort of enhancement of ability to provide. The goal, I think my sort of vision is that USM will be an endpoint that different monitoring systems can hit to get information that they don't have access to. And so you might have a NOC and you might have USM up and they'll be monitoring your storage with that, or you might have existing, you might have OpenView, or you might have other management systems you want to integrate into, and so it could be a source of data for those as well. And then also include some performance enhancements for larger Ceph clusters. So. And then another thing, and this is something that as I've walked around and talked to people here, there's been a lot of talk, a lot of interest around CloudForms. So this is on the roadmap for 4.2, CloudForms 4.2. So the idea here is that CloudForm as a higher level manager of managers could then talk to USM, discover storage that's running on Ceph or Gluster, and represent that in a visual way in CloudForms, and then provide metrics on it, storage metrics such as I/O, throughput. Events could bubble up through CloudForms as well. And then they have something called cross-linking, where they basically sort of map things through to the applications down to the storage level, so you can actually get some intelligence about where's all this I/O coming from in my Ceph cluster, for example, would be a good use case for that. And also CloudForms handles lifecycle management, so day two operations like adding a share, retiring a volume. CloudForms can do some things like that. It's likely that USM will still be obviously a lot more fully featured from a storage perspective, but CloudForms can provide that value of sort of giving you the big picture. What's going on in my enterprise? What are all my servers doing? How's my storage interacting with that? So. Also mentioned the Red Hat Insights. This is I will confess this is not a new idea. I came from NetApp, and so those of you NetApp guys out there, you know about auto support. This is a very similar kind of thing where if the user chooses to, they can allow the cluster to upload some basic information and this would be entirely up to their decision or their choice. But if they were to, example, give us their the Ceph configuration file, we would know some key things, maybe information about the kernel they're running, the version of Ceph they're running, or the version of Gluster they're running. We can do some predictive kind of things to let you know you might have a problem if you have this combination of this RPM and this version of Ceph. And we a lot of the work that happens with Insights is actually kind of a back-end big data operation. So they're getting this data in, they're analyzing against our support cases, and then they have guys that write rules that say, okay, in this case, when you're running this with this combination, you're either going to have a security problem or you're going to have a availability problem or a similar thing. So they can give you a predictive alert on that. So I think that'll be a real big, if you think of one thing in your infrastructure you don't want going down, that'd be your storage. So I think probably Insights is a really important thing for the roadmap. The only difference is it would be consumed directly in the storage console rather than having to go out to a different interface like the customer portal or something like that. You could still go there and get alerts there as well. But another thing that people that are running larger Ceph environments are telling us and larger clusters that the logging gets to be a challenge. So we're looking at common logging frameworks around RSYSlog and FluentD and ways to sort of visualize patterns that are going on in your logging, so you can kind of see, you're getting spikes at a certain time of day every day, and you start to see that repeated, and you're like, well, what's going on? And then you realize, oh, we got a Ceph scrub going on here, and so we're getting logging spikes, or, you can do a lot of troubleshooting, better troubleshooting with that visualization. And then the last theme, and this is around improved hardware management. So we want to have the ability to do better detection and handling of failure events. Even though we're software-defined storage, there's no software-defined disks. So, if a disk fails, you got to handle it. So we want to be able to sort of map all the way through a Ceph cluster or a Gluster cluster and see, where a failed disk is. Maybe be able to light up an LED on the disk so the administrator can find it in the data center if they're going to the rack. Okay, there's the one. Because it's lit up, or provide similarly, like if you're using flash, they only have a certain number of write cycles, so we keep track of that and provide an alert. Oh, you're getting near the end of your write cycles on flash. You might want to take action on that. So we're seeing a lot in Ceph. We're seeing a lot of people using flash for journal devices, and so when a journal goes down, an OSD goes down, so it's kind of a big deal. So it's a good thing to know where you are. The flash media itself obviously is very reliable, but knowing about the write cycle is an important thing. And then I mentioned the guys that designed the Tendril logo, if they were here, they'd kill me because it's actually not purple. There's something about this slide, I cannot get it to undo that. It's gray. So imagine the Tendril gray instead of purple. The current project that I've been showing you and talking about in this 2.0 release is the SkyRings project. There's a number of child projects within that. In the new scheme in September timeframe, we'll be moving to a new GitHub repo. There's nothing on the right side. If you go out there, you won't see anything now, but I'm just letting you know so that you know what the plan is and when the migration will happen in 2017. I'm sorry, that's a typo. September, this year. So we'll be moving to the Tendril, the namespace. There'll be Tendril Web, Tendril Common, things that make sense. So the original naming was more around sort of an open stack. Everything's got its own name, and that's kind of fun, but it's also confusing. So we want to move to a little bit more, an easy to identify namespace where I want to do it on the web, I want to contribute to the web project, so it's Tendril Web, or if I'm interested in the core stuff, it's Tendril Core or Common, whatever. Patrick McGarry, who's the Ceph community manager, will be handling that for us. So we do not have the documentation up, so I'm not overselling this. I've started in February, so I'm learning about developing communities and building. I'm real excited about it. I've been excited about open source since I was, in the 90s, a long time ago with Red Hat Linux. So I've wanted to do this for a long time, and I'm committed to it, but we just have some work to do, so be patient with us, and we will get this community kicked off and get people so they can start contributing and really build. The goal is to build a vibrant upstream community around this project and get people contributing, start working with partners. We have a lot of interest from, particularly in the early going, at least hardware partners have expressed a lot of interest in contributing to the framework I talk about with the hardware alerts thing. But we also have some customers that are interested and other, you might call them competitors, but there's interest to contribute. So stay tuned on that. And that's all I have. Are there any questions? I think we're actually, let's see, it was 4 o'clock. Got plenty of time here. Yeah.
When you go and add a cluster support, will you be able to import existing clusters?
Yeah, that'd be the goal to.
Similar to Ceph?
Yeah, divide part of that same. Yeah, pull it in and do discovery. Yeah. Mm-hmm. Yeah, the upstream code's on GitHub and the Skyrings project that I mentioned. The downstream product, the Red Hat Source Console 2, that's based on the Skyrings project, is going to ship in early August, so it'll be available then. We're actually in beta now. If you're a customer and you're interested in beta, let me know. We can probably get you hooked up with that release. But it'll be coming out in August, and so yeah, you could go out and run the upstream version of that as well. Mm.
That works in the community version.
I'm sorry?
That works in the community version?
Yeah. I mean, the build, you can talk to Nishanth if you have questions about that. He's Nishanth Thomas, he's our development lead. Anything else? Yes?
Is there containerized available?
That's a good question. There's been, to my knowledge, there's been a lot more effort around containerizing Gluster, and I think I saw you in the Gluster session, so you already know that, but I'm telling the rest of the audience here. I'm not, somebody correct me, but I'm not aware of containerized Ceph. I think it's probably harder to do that, and Ceph runs at such large scale. Anybody know of that? Yeah? It is in the works, okay.
You talked about performance.
Mm-hmm.
Can you elaborate a little bit how much that works, how it comes out?
So everything that, at least in the Ceph context, everything that the console is doing is hitting the Calamari. What used to be, if you're familiar with older Ceph, you remember there's Calamari. Calamari is now Calamari Lite, and so it's sort of headless API. It's running on the Mon. It provides data to the console. So it's actually, the console's making API calls to the Calamari service running in the Ceph cluster and getting information back. In most cases, there's some exceptions to that, but most of the things are API calls to Calamari. Yep. Yeah, question? That's one of the important use cases that we're thinking about. The geo-replication gets to be hard because then you have to design, build it into the software to know about different zones, similar to what Haketi can do, I believe. And it's not an unsolvable problem, but it's a little bit of a challenge problem. So it's something that I want to get in there. It's kind of a stretch goal. We'll see. I hope to get it in. Well, I don't know. You can ask Nishanth. He give you a confidence level on that one. But yeah, that is a goal to get that in there. I think it's a really useful thing for customers to be able to do the replication, obviously. So, anything else? Well, if not, then you get some time back and you can go enjoy the day and enjoy the remainder of the summit. So, thank you.